kind of an underappreciated feature of the Open Data Cube. Um, it's not. So to preface this, the idea of virtual products, I think, is kind of still under some development, but I think it's a very powerful idea, and I think it's something that's very uh, neat and unique to the Data Cube. Um, so, uh, what are virtual products? Um, Virtual products are basically a way to define a recipe for transforming your data. That would be like built that that you could access sort of like a regular product, like you normally do from the Data Cube. And you can kind of use it to define a pipeline. And if you can break down your analysis into kind of some simple steps, and it's something that you do a lot, it may be very convenient for you to use a virtual product. Um, the the idea being that if it's something you access on the regular, you could actually just, without storing what it actually is, you can just store how to make that thing, and or make that view, if you will, and access it sort of like you do a regular product. Um, so there's a couple of ways you can define a virtual product. One way is by defining an actual YAML file, just like you do when you ingest data to the Data Cube. You can define a YAML file that's kind of similar, but instead of defining the metadata, you're defining how to actually create uh, uh, and transform the data that from the existing data, and creating the view that you want to see. Um, uh, there are some like there's some like basic, but sorry. And then the second way is that you can actually put you can create this in Python in the Data Cube itself. Now, accessing it through when you create it in like a notebook, for instance, is a little bit different than accessing a regular product, because you're kind of defining it there, and you have to actually tell it to like construct it, and it's more like accessing a measurement. But we'll see that in the demo at the end. Um, so actually, I should keep the chat open just to make sure. If anybody has any questions, feel free to type or interrupt me. Um, the next slide. So there's some basic components that you can use to create a virtual product. The one is actually like, and this is especially when you're writing like the YAML file. One is the product itself. Like, what are the inputs to the virtual product you want to create? So, a very common one, that everybody's very familiar with is you may want to just pull in some Landsat data. So you'll pull in like Landsat 8, for example. If you're pulling in multiple products, you may want to, for example, collate them, which means to kind of interleave them. Another thing might be using something like pixel quality in this example to then, if you're going to be creating a mask, you can reproject them, you can aggregate them. So like, for instance, if you wanted to do like a group by, like if you wanted to group them by season or something like that, that's what you could do. I accidentally put transform on here twice. That's because the last one's actually a user transform. The transform is probably the most interesting one, because it lets us actually modify the underlying data. And full disclosure, this is I'm pulling all of this basically from the documentation of the Data Cube. So if you want to refer back to this, or you want to look into it, I just kind of want to walk y'all through the actual, like, what the virtual product is, and perhaps a quick example of how to use it. So, and I'll make this a presentation available afterward, as always. Um, so back to the transform. The transform's powerful because it actually lets us modify the underlying data, uh, which means we can do really interesting things. Now, I would caution against doing something like too complicated, because your load times would go up and whatnot. And I actually don't have a lot of experience. Like, I'm just now exploring the realm of virtual products. So I also would I would also caution, because like it could potentially like be like slow down your load time. So like that might be something left, but like if you have something that's very, very complicated, that might be left better to doing some computation with Dask, for instance, and using like multiple workers or something of that nature. So in the transform, there are some like built-in presets for how to transform the data. So one is to make a mask. Another one is to then apply a mask. We can also convert the data type of the raster to, for instance, float. We could also select, so we could actually, start out with many bands, and then we can return only the band that we want. And then we could also have this expression transform, which does simple arithmetic. And we're going to be implementing something kind of similar to that. The reason you might want to use a virtual product is twofold. Is that it's something you do quite often to your data. So for instance, if it's a view or a this pairs really nicely with using kind of the band math indices that we were doing. So like if you're always going to be looking at, for example, NDVI or one of the urbanization indexes that I went over a couple of presentations ago, or something like that, it might be worth creating a virtual product for that if that's like what you're primarily interested in, because it makes it quick and easy to access without too much extra, like without having to like rewrite that code over and over again. And the other one is that it only returns the data we want to see. So like if we're kind of being memory limited and stuff, it's only going to give us an X array for what we for the data that we actually want. And that can be very convenient too, because you may be in kind of on a computer in a computing environment that's kind of memory constrained, for instance. So how do we actually go about defining our own transformation? So the transformation actually looks something like this. And again, this is in the documentation. You need to refer back to it. So the idea here is that we need to make sure we import the construct, transformation, and measurement. Then we define a new class. And I don't know what everybody's kind of comfort with Python is, but basically this is saying we're creating a new class, and it is inheriting from this idea of transformation. And so that means that we're going to take whatever's defined in transformation, and then we're going to extend it a little bit. And here we need to make sure we're going to be implementing our compute and our measurements. So the compute is actually where we actually put the definition of our bandmath. Here I had I forgot to neglect to say that you can also do like a regular init. Again, I don't know how much experience everybody has with like creating their own classes and inheritance, but the init is basically what will run when you create the instance of that class. And the idea being that in the init method, you could put some sort of like argument, like if you wanted to pass arguments to your virtual product, the settings list would be where you pass those arguments. So going forward to the example of NDVI, here we can see in the body of the compute is the actual definition of how to compute that band math indices, which is you take the difference between the near infrared and the red bands. Excuse me, I seem to have some hay fever today. My allergies are getting to me. But and then we divide it by the addition of the near infrared and the red. And then we want to return that result with the name NDVI. And then we kind of the measurement actually describe. Notice how like the measurement function actually describes what the compute function is putting out. So and then finally, we basically say that NDVI equals, we construct the transformation, and we give it the product input that we want to Excuse me. My apologies. We actually construct the NDVI, and we tell the product we want to use with the measurements from that product that we want to use to construct it. And then finally, we do an NDVI, and we use the load method, and we point it to the data cube, that's DC, and the search terms is very similar to the regular kind of query you may have been using during your classes. But we actually don't have to include as much information here because we've actually defined and pushed a lot of that to the like we've done a lot of that in the actual creation of the virtual product. So it's a smaller query, and I can show you that here in a second. So if I may keep our fingers crossed, because demos always go kind of awry when you try to do them live. All right, let's see. Let me share my other window. Man, my allergies. Pardon me. All right. Thought I was going to sneeze again. All right. Can we see the screen, hopefully? All right. So here at the top, okay, so actually I ran this earlier, but so it does work, believe me. Let's hope when I run this again, it does indeed work. So let's go to view, single document mode. Let me blow this up so everybody can kind of see what's going on. And then I'm gonna hit run. Restart. And then we're gonna run this. Okay, and we're off to the races. So we import our required libraries. We set up our data cube, DC equals data cube, and I can just give it the name of what I'm doing. Yes. Somebody have a question? No? Okay. All right. Here I'm defining kind of I'm defining some of the things that are going to go into building the query that I'm going to query the data cube with. And then here I've created this is
Brian,
probably overkill. Yes.
One quick point. The text is too small for me to see. Others may be having the same issue. So if you want to blow up the size of the text, I think that might be helpful to everybody.
Okay, I'm already at 150%, but I can go even larger.
You have a high resolution monitor.
Yeah, that's true. Is this better? Readable?
No difference.
It works, Brian.
Let me try resharing.
Or maybe I just have a very small monitor compared to everybody else.
How about now? Any difference?
See it yet? It's still coming.
Okay.
Sorry to interrupt.
No, that's okay. It's important that people can see what I'm doing.
It's not coming to me. Can everybody else see it?
I think it might take some time because of the resolution. Otherwise, at least we get an idea.
Okay, there's a delay in transmission, so you can talk about it. Since you can see it, talk about it. Then when it comes, you will follow.
Okay. All right. So I create a data cube like normal. I do DC equals data cube dot data cube, and then I give the name of what I'm doing. And then I define some variables to help kind of build the query, kind of like you would normally when you're creating a query for the data cube. I then define an area. With Edward, we were working on the Ruko Conservancy, and it's just an extent I had handy. So I was doing this area. This may be kind of overkill doing the location, like creating a kind of a location named tuple, but it makes it easy, and we can talk about that, but that's kind of beside the point. I then create the extent for where I want to see.
Brian,
and then as like just
reshare. It's just not coming.
Okay. Whilst we wait for you to reshare,
Yes.
Can you use shape files
To in what way?
to get the exact map you're
Yes.
looking out for? Because we
Yes.
have different districts. I would like to have a shapefile of the district and then map it on to get exact data within that shapefile. I tried something like that. It wasn't giving me based on my level of memory allocated memory.
You were running out of memory. So I think that's a common thing. It's very easy with the data cube because there is so much data in the data cube to import something that's too large for the default instance. To use a shapefile, generally you would in the query, instead of doing like, so here I'm creating, I don't know if it's shared again. Still having difficulty maybe, or Oz, can you see it at least?
I can't see it. Oh yes, it's there and it's big and it's beautiful. Thank you.
Wonderful.
Okay.
Yeah.
So to answer your question, very good question, by the way. So here what I'm doing is I was creating these variables, right? To create the query, I specify the resolution, and then I create, and the query is basically just a dictionary with all the variables that I need to pass in order to get the information I want out, right? And so instead of let me get to that in just 1 second. So bear with me. I create where I want to see, right? I then create the extent of that because I just have the point that I want to see. So I actually want to see an area around it. So I define the 4 points to create the box, right? And then so I use my little function I created to do that. And then there's this handy script called display map, right? Which basically lets me like double check where I am looking. It gives me a nice little map that says, okay, this is the box you've selected. That's very nice. There is even a similar function for something like a shapefile, and we can talk about that. It's a separate script, but that's neither here nor there. So then, when we get to creating the data set, I'm using the load ARD function, which is from the data handling script that's provided on the sandbox. And this does some nice things in the background, like automatically masking clouds for me. You were asking about, can you get a shapefile? So what it will do is you can actually, instead of, for instance, using an extent here, you could, for instance, do something like there's a geometry you could do geometry equals, and then what you would need is a GeoPandas data frame. So oftentimes you'll abbreviate that GDF, and the GeoPandas data frame is basically just the shapefile in the form of GeoJSON. And in order to get so basically what you would do is you would import the GeoPandas library into the notebook, and then you would do, I think there's a geopandas.read function which can read shapefiles, and so you would need to upload your shapefile over into your file browser on the left hand side, right? You can just drag and drop it, and then you would just point it at that shapefile and do the read, and it should read it in. There may be some difficulties with it bringing in the coordinate reference system with it. So it's important, I think, for you to kind of know what coordinates reference system the shapefile was created in. And it will actually create a bounding box around your shapefile and load in that data. What you then can do, if you just want that data, you can create a mask with the shapefile and to mask out just the data that you want. So does it save memory? If you're having trouble getting the full extent of your shapefile, that may not help as much. Using Dask may help more, and we can talk about that more after the demo. So, I go ahead and load my data, and then what I want to do. So everything up to so creating the extents everything has been like the normal way of doing it. So I'm demonstrating the normal way that you would do this. So you would use the calculate indices script potentially, and you tell it you want to calculate NDVI, and you're using Sentinel-2, and then it would create a data array in the data variables of NDVI right here now. And then you could, like, for instance, like look at the different plots, like, okay, it's like we have some cloud cover here. Oh, here's a few clear days. I could look at the one of the ones that's more clear and like more closely and get this nice big picture. It looks pretty good. But so that's all well and good, but I've had to import this big array, and I also had to import the red and the near infrared in order to calculate the NDVI. What if it's something I'm doing very often and I don't want to have to type out like the calculate indices and all that kind of stuff? I just want to start from near infrared. So I could import from DataCube Virtual the required, construct, transform, and measurement. And then I can create my own NDVI class that inherits from transformation, right? And here's that definition I was referring to of NDVI. And I'm just going to return the result to the data, as a data set. And then in the measurement category, I just need to define what NDVI is, right? Its name is NDVI. It's going to return a float 32. The no data value is nan, and it's going to be units of 1. Because it's unit, it's not really, it's a ratio, it's unitless. So, and then I construct. Yes.
You made mention of transformation. Is it a transformation user because you're going to get the NDVI class? Is it from the user or the upper transformation? You had 2 classes of transformation.
I had. Sorry, can you restate your question? I think I got a little bit confused.
Class of transformation when you made the earlier submission, and you said one is user. So I'm asking that from the DataCube, are you getting it from the user point to create the class of NDVI?
So up here when I was creating the NDVI, right? Are you talking about the difference between doing it this way and doing it this way down here?
Okay, I understand it now.
So I'm doing it 2 different ways. So this way up here was how to do it, what I would consider kind of the normal, straightforward way, using the scripts, right? Like all this loads the regular data into your notebook, and then you do the math on the data once it's in your notebook, right?
Yeah. Okay,
here we're actually pulling it. We're actually saying, before I pull anything from the DataCube, do all this stuff to it, right, to give me what I want to see. And it's kind of like a static way. And then I could actually change the extent. Notice here that I've defined two steps have switched position here, right? Here I had to define my area and then tell it to calculate NDVI, right? Where here I tell it how to calculate NDVI, and then I ask for the area, right? I've constructed so I construct the virtual product in this line here, and then here this is my new query for asking it for NDVI data. So let me hit here. So I construct it, I redefine my query, right? And then I'm gonna say NDVI from this product, right? I want to load my query, right? And then I'm going to get back my NDVI data and just the NDVI data. So, like, cross your fingers, because this is a demo I prepared. This may take a second. So again, this is where the kind of like the loading times and the extents, where it's like you kind of have to have a trade-off sometimes between the amount of data you're requesting, the complication of the calculation, and how much memory you have, right? Like you can make things take longer if you need to use less memory, right? But if you have more memory, you can go faster. Like so, this is going to take a second. And one thing to be cognizant of, like so, I can run this in a second, but I ran this earlier. This is what you will get back when you ask it to plot that's the same time slice, right? We're at we have the same extents. We're at time equals 45, so that's 2020. So that's September 13th, 2020, right? And we have September 13th, 2020. Now, notice the clouds are kind of causing an aberration here because they're actually not masked out. So the load ARD function actually attempted to mask out a lot of the clouds for us, whereas here they're not masked out. So I might need to actually make another virtual product to mask out the clouds if I wanted to use this. This is much more of a direct load. This is more equivalent to using something like dc.load, right? And then entering your query, which is loading the direct data without doing any sort of processing. The nice thing about load ARD, which is load analysis ready data, is that it's doing some things in the background to basically give you only good quality pixels to process, if that makes any sense. Yeah, I mean that's okay. So our data has loaded. I forgot. I guess I should have timed it to kind of give you all an idea. But we can go ahead and produce a plot of it, and voila, right? We have the NDVI product. What I want you to pay attention to is actually the land here. That this is very much the same values you're getting back on the land for the NDVI values of this area. Wallace, did you have any other? Did that answer your question? I know I was getting. I don't know if I answered that second question as well, or if I understood it properly. But
yeah, I think I'm okay with it.
Okay, good. Anybody else? Was there stuff I missed in chat?
I think, Brian, the presentation was really cool. It gives an overview of the commands, and Wallace was able to point out some of the points like the shapefile. And I think for now we can wait for a question, or we can break the presentation a little bit so that we can see what we can present next week. I think also Stella wanted to present something. Stella, or Stella, you're still there with us?
Yes, I am. Hello.
Yes, Stella, welcome.
Thank you. So it's quite interesting because I've not yet finished, but maybe your input would be good as I prepare for it next week. I'm trying to understand the impact of forest disturbances, especially biotic factors, that is, how to use satellite images in understanding the impact of insects on forest. So because they affect the early stages of forest development, eventually they affect environmental factors if forests are affected at the early stages by insects. So I am trying to look into how we'll use vegetation phenology, especially NDVI, in understanding how to monitor insect disturbances towards forest at the early stages. So maybe your input will be welcome because most studies have used models that are outside remote sensing. And so we're trying to understand how remote sensing will be of a key importance in monitoring the forest disturbances, especially insects. So maybe some of you could help me evaluate or an insight about that as I develop. And for sure next week, I think we'll be able to present a good understanding on that. And we're looking at especially forests develop at drought stages, like during high temperatures. So yeah, that's also another key that I'm looking into. Yeah.
Do you have a specific study area, please?
For now, I don't have, because I was thinking about Germany or Europe forest, because there has been a decline in the forested cover in Europe a lot, especially during hot season. So yeah, in Africa, I'm not yet sure. I'm still researching on that. Yeah. But the
Okay.
main aim is to use vegetation indices in monitoring that, and especially Sentinel-2 data.
I think Wallace has an answer for us.
Hello, Stella.
Yeah.
I'll give you a coordinate to work on for me then.
Okay. Really? Thank you.
So, Brian, any thoughts, Edward?
I'll let Edward go first.
So since Edward is quiet, I was thinking more of the insects, like also the locusts in East Africa. So looking at the phenology, the time when there's the onset and the temperatures, and also you've asked a very good question, because actually yesterday my colleague from National Bureau of Statistics, Benedict Mugambi, called me and told me that the Minister of Environment has mentioned now the locusts have moved from the Horn of Africa, Kenya, now moving to Tanzania, and they're really scared because, as you know, Tanzania is like the food basket of the region. So they really want to act fast, and you can't do any much other than use remote sensing quickly to see where this is going and happening. So this is really timely for us to think about and ponder. So you might not get the answer today, but it's something to keep us busy in the next few days. Thank you so much, Stella, for this hard question.
Thank you. I'll reach out to Edward concerning the same. Yes, and you also.
My primary thought is that, so one thing is that NDVI primarily works on by detecting the red edge of chlorophyll. So as long as there is a reduction of chlorophyll in the area, so for instance, insects eating a lot of leaf area or whatnot, then you will be able to see, you know, if it's on a large enough scale, like, so Landsat data, right, is a 30 meter by 30 meter pixel. Yes. So, you know, you're talking, you know, the size of like a large building. So if these are occurring at a large scale, I would imagine that you might have, if for instance you had an insect, for instance, we have certain blights in America, like the oak blight and things like that. And oak trees would often be mixed in with other types of trees, for instance. And this may be harder to detect because it may be a single tree out of a cluster of trees that's affected because it's a different species. And so something like that might be more difficult to detect. So, you know, if you're talking about locusts eating large swaths of crops or something like that, that's easier to detect. Whereas single species of trees amongst clusters, that doesn't mean it's undetectable. It just may be more difficult to detect, and you might have to do more stuff. The other one is you may have to do some seasonal detrending, because, you know, a lot of times vegetation is following a natural life cycle, and so and if you know, depending on what we're talking about, whether it's a blight, an insect, or some other thing, it may be interesting to capture some of the dynamics of that. So like that's also something to look at. With NDVI, it's there. I guess there's three primary indices that we have for looking at vegetation on the data cube right now, which is NDVI, EVI, the Enhanced Vegetation Index, and the Leaf Area Index. And NDVI works on the red edge principle. I'm not as familiar as with the other two. But here's the thing: is just because it's not captured in one of those indices, don't get discouraged, because it may be worth any sort of use case you come up with. The golden thing to do is to figure out that, hey, there's going to be some change in the reflectance property, and then if you can collect some on the ground data, like go to where the actual pixels are, right, and say, yes, we know these pixels have whatever disease, insect infestation, whatever it is, right, and these ones don't, and we can kind of characterize the difference between the two, then you can actually build something, you know, use Edward presented last week kind of a way to use like machine learning and the random forest to create your own indice. right? And that's actually could be profoundly helpful to people to create, kind of package up all that knowledge into something that other people can use. So yeah.
Thank you so much, Brian. That's very
No problem.
insightful. Okay.
So don't worry, Stella, it's doable. And Wallace actually can type in the coordinates on this chart so that we can follow up closely with Wallace so that he can do some field work for us.
Yeah, make him volunteer. That's what you got to do.
Yes, yes, I'll bring it up.
Okay.
Thank you.
Thank you so much, Stella, for this opportunity. Also, looking at the time that we've had some responses, I just want to point out maybe some colleagues who never had time to introduce themselves. Ekran, are you there, and where are you calling from? After Ekran, I go to Maxine. Then from Maxine, I go to Fanel Sosu. Do we have Baba Musa? Are you able to hear us? Okay, so I think they had some challenges with their audio. Otherwise, I wish to thank you guys very much for attending today's session, including the ones who've joined us today. And I'm very happy with Career, the progress with the students who are actually doing some great work. So this gives Kelaboge some motivation with her students as well. Also, Kelaboge, to mention, is that Stella Mutai, she's working for IFAD, and she was a classmate to Stella Mudoni, where they were the undergraduates. So Kelaboge knows Stella through ISIPE, where she's doing some projects with her, and these opportunities for collaboration, which I can introduce you later on. So, so August, what do you think we have for next week? We'll have some very nice topics. At least Stella will present something for us. Edward, do you have in mind what you'll present for us next week so that you can keep us waiting? And also, August, you have a topic in mind for next week?
I didn't have one in mind, but I'll discuss it with the team.
Okay, okay. At least we'll have a presentation from August.
Hello?
And yes, Baba Musa. Mambo.
Yes, good morning.
Morning, sir.
Yes,